Ladies and gentlemen, please welcome to the stage Vice President of Marketing, Amy Krishna Mohan.
Hi, everyone. Nice to meet you all. I heard that there is a big traffic accident in highway today, so I know some of you had a lot of struggle to get here, so I really thank you so much for being here. And I know some of you also joining online and with the live streaming, so thank you for joining us virtually as well. I'm really excited to see everybody here at Data Streaming Summit. My name is Amy Krishna Mohan, VP of Marketing at StreamNative. So when we do these events, obviously, I'm running marketing team. So every single day, I go to event registration and see who's registering. Like spy, I'm always picking on. And I always surprised that I see so many different titles. I see some of the people are like back-end engineer, working on databases, data streaming, obviously, and then some of them are obviously developers. But I see some of the data scientists. I see a lot of the business leader and startup founders. So I was really amazed to see that so many different diverse group of people are really excited about the data streaming. So I'm really happy that everybody was able to gather here together today. So earlier this year, we got a chance to sit down with many of our customers and community members and really talk about what is your vision and what is your challenges and what is happening in the industry right now. We have all gone through a lot, right? After COVID, there was a big recession, everybody had to downsize. We went through all tough times, right? So we talked to them, and what are the things that you are using right now, and how do you want to go forward in the future? And obviously, is our community members and the customers, so many of them are using Apache Pulsar, and then Kafka, and other messaging system as well. But one thing that really stick out in all the challenge that they talked about, there's a lot of common challenges among all these customers. So let's talk about those challenges. So one challenge that they had is about how do we scale the data streaming? We really need the real time, so we built this technology. But I'm having really big struggles scaling these workloads, especially systems like Kafka. I have to repartition it, and it requires a massive amount of effort. And then if the customer who are using like legacy system like MQ, they just couldn't find any alternative solution to scale that. So scaling was actually one big challenge that everybody had. And the other challenge they had was about how do I integrate this with my data lakehouse? I'm using S3, BigQuery, Snowflake, Databricks, all these data lakes for analytics, but I want to feed the data, real-time data, into this data lake. How do I make this unified platform to provide the real-time data to this data lakehouse? Can I make a joint, really good one platform? The problem is that many of the teams, they started with I need a Kafka, and then my other team is using Snowflake, so let me connect that. And the next time, another department came, I'm using Pulsar, but it's connected to Databricks. And then it's just compounding different technologies and became really, really complex. And everybody want to tackle that issue. How do I make this really unified data pipeline? And this issue became accelerated because of the rise of AI. With the AI, everybody really needs a good AI infrastructure, right? They need to have their data flows really consistently. And then this AI, with the AI, they want to make more optimized process, more effective decision, more insightful decision. They want to make it fast, right now. But they need to have really, really good foundation to build this. And when I think about these three challenges, we looked at the events that we've been hosting past couple of years at Pulsar Summit, and we thought that having just talking about Pulsar is quite limiting. We want to bring everybody who is concerned about data streaming and AI, bring everybody together and then have a joint big conference together like this today. So I'm super excited to have everybody here to have a lot of discussion about where the data streaming future has to go. We have a really fantastic day planned for you. So obviously you are here for keynotes, and we have a lot of industry experts and the community leaders coming here to talk about their use cases, exciting product announcements. And then we also have 3 breakout sessions. So one is about deep dive, The other is about use case and ecosystem. And then finally, we have a solely dedicated track just to talk about AI, because the theme of this conference is data streaming and AI. And finally, we have a closing keynote. I'm not sure some of you may have seen the social media announcement, but we have an amazing speaker lined up for the closing keynote as well. So please stay until the end of the session. And then we're going to obviously end with really good happy hours. And then you can continue the discussion with all the people that you meet here. So before we kick things off, I would like to thank our sponsors. Obviously, without them, I don't think this event would have happened. So thank you so much for our diamond sponsor, Ververica and TIDB, PinCap. And then our gold sponsors, Google Cloud, Snowflake, and Nexaminds. And our silver sponsor, PuppyGraph and Conductor. And we also have many more community sponsors as well. So thank you, everyone. And I know some of you also joined us in the training yesterday, and we had a lot of interesting training for the AI integration with data streaming, and AWS gladly partnered with us to provide the training, so thank you so much of that. So with that, it's a great honor for me to introduce my next keynote speaker, CTO of StreamNative, Matteo Merli.
Hi, everyone. Thank you, Amy, for the introduction. And it is an honor to be here with all of you for Data Streaming Summit. I'm Matteo Merli. I'm CTO of StreamNative. And today I want to take you on a journey that explores the evolution of messaging and streaming systems and how Apache Pulsar came to be, and why it is emerging as the go-to solution for the most demanding and mission-critical workloads. So when we look back at the past decades in messaging, you can see that messaging is hardly a new concept, right? It has been tried and tested in the past. And the early messaging systems were based on a very simple intuition, is that the software system keep becoming more complex and hard to understand. And if you want to make this complexity manageable, you have to kind of break it down. You have to break down the monolithic architecture and into multiple components that are more easily understandable. And so it kind of like led to apply what is the most used abstraction in computer science, which is a queue. And the idea is simple, but its effects were like huge, and it kind of changed the way people architecture the application and the way that people thought about software architecture. Because now you can design a scalable, reliable applications where the failure of one component does not compromise the reliability of the entire system. And where also you can have a much larger number of developers collaborating on building a very complex system, each of them carrying just about one small subset of that complex system. So one way I like to see this also that by adopting messaging, people have been exposing the internals of this monolithic architecture. Because now you have visibility on what happens. If you have multiple components talking to each other, you have with a queue in between. Now you can see what is flowing between these components, and you can gather like a lot more understanding and visibility on your system. And also you can find other usages for these events and this data that previously was just inside the internal of this monolithic architecture. And finally, like, while the queue abstraction is great and powerful, it really did open the path for to build reliable distributed application. But the messaging system, the earlier generation of messaging system, were not truly distributed in nature. So all these systems were like vertical scaling architecture based. That means that it runs on one server, and if you want to have more capacity and more resources, you have to put it on a bigger server, but there is obviously a limit. You can just infinitely scale that architecture. And as the data needs grew and became more complex, and we saw the rise of data streaming platform that needed to process vast amount of real-time data. And this is where Kafka came in. So when Kafka entered the scene, it really solved the problem that the existing generation was not solving, which is the scalability. And Kafka showed that in order to solve the scalability of the streaming infrastructure, you had to kind of like base that on a distributed log concept instead of the old way of using the storage. At the same time, though, Kafka exposed the log as the fundamental abstraction in the system itself, rather than the queue. And the difference between log and queue might be subtle, but if you think of it, a queue is more like a concept that is more close to how developers think about the problem, while the log itself is more like a low-level storage concept that you use to build up application on top of it. But it was a time where people were really scrambling to keep up with the growing traffic that was generated by explosion in web and mobile apps traffic. So the need of scalability was so real and so felt that Kafka adoption soared very quickly, and even though it exposed an abstraction that was much lower than the previous generation of system did expose. But Kafka offered a robust system that solved this data streaming at scale, and over time the community grew very quickly, and to the point where you can now find Kafka in every corner of the world. But the industry evolved and the cloud became a major shift in this. And we really realized that Kafka, even though powerful, was not built for cloud-native workloads. And this is where Apache Pulsar comes in. So Apache Pulsar was designed from the ground up to address these challenges and offer features like multi-tenancy, geo-replication, and infinite scalability, all within a unified messaging and streaming platform. The first principle we used to design Pulsar was to avoid the pitfall of these legacy architectures. And instead of designing for in a similar way, we want to design embracing the dynamic nature of the cloud environment, and create a system that can be truly elastic and operation friendly, in a way that the kind of reliable elasticity that you can trust your business on a Black Friday or a Super Bowl event kind of day, where you have a massive spike of traffic and you have to struggle to keep up with those. The second realization was that these old school messaging and queuing abstraction and semantics pioneered by JMS they were really useful for developers, and they solved the real problems that the developers were facing. So, and at the same time, it was possible for us to implement those features in a scalable way on top of the distributed log solid foundation that Pulsar has. And over the year, Pulsar has seen incredible growth in all the dimensions, and the community has really expanded rapidly. We had developers and companies contributing from all around the world, and the growth has been really driven by the ability of Pulsar to meet real-time, real-world challenges that many organizations were facing with the existing system. And that's why Pulsar has become the center-level system for many large enterprises and unicorns, with this ability for multi-tenancy, unified messaging, and in everything into a single platform. And today, I'm excited to announce the release of Apache Pulsar 4.0. So this is the second LTS release that we have did with Pulsar. The first one was 3.0, which was the first with the LTS model. That means that the support cycle is 18 months or 24 months so there is one LTS every 18 months, and there is a support is 2 years for bug fixes and 3 years for security fixes. But Pulsar 4.0 really represents a major milestone in our mission to create an open data streaming architecture with key advancement in modularity, observability, and performance. And 4.0 really is kind of like a future-proofing the architecture of Pulsar with this modular architecture. So right now, every single component in Pulsar itself is pluggable, from metadata to the data storage to the protocol handling. You can really have implementation of data tailored to different use cases, different environment, and you can apply to the specific needs of each enterprise and each use case. Finally, this version also includes built-in OpenTelemetry, for comprehensive observability. And it really allows organization to monitor and optimize the performance in a very fine-grained way. And Pulsar 4.0 would not be been possible without all the hard work for all the Pulsar committers and contributors and everyone that made the Pulsar community such a great community as it is today. And as the industry progressed, something remarkable happened, right? And we saw that across different messaging and streaming ecosystem, there's been a convergence of ideas. The same feature, the same approaches have been applied in multiple places. And whether working with Kafka Pulsar or something else, the community has been recognizing the need for more open, modular, and flexible data streaming architecture. And this kind of led to a new generation of data streaming engines that kind of like support things like multi-protocol, like seamlessly handling very different streaming protocols within a single system, or open storage formats. I think this is very important because this really facilitates the integration and ensure the long-term accessibility of the data. And modular design. This is for enabling organization to build streaming solution for their specific needs. So Pulsar has been a central player in this convergence, and the result is an open ecosystem that allows organizations to build these technologies in a flexible and interoperable way. And at the beginning of this talk, I was mentioning about how introducing the queue in the monolithic architecture exposed the internals of the system, right? And it kind of gave this visibility and this observability of the system itself. And I really believe that the next evolution is how we can expose more of the messaging and data streaming infrastructure to their side. Because this is kind of like, from opening up the protocol to the storage, this is kind of opening more opportunities for people to make use of the data and to make better integration and to kind of come up with new ideas on how to evolve the architecture and evolve how data is being used and how people think about data and storage, and for both short-term and long-term. And looking forward, I really believe that Pulsar is uniquely positioned to support the future of data streaming. And this architecture, designed for cloud-native workloads, it makes it very adaptable and to the evolving needs. And whether it is like supporting like microservices or transactional system or like massive scale real-time analytics, Pulsar is really becoming the default choice for businesses that needs a reliable and versatile data streaming platform. And today we are excited to welcome some incredible enterprises to the stage to share their stories. And these enterprises have been using Pulsar and Kafka in innovative ways to power critical systems. And we are thrilled to hear about the impact it is having on their operations. So without further ado, let me introduce Hugo Smitter from FICO to the stage to share their journey. Thank you, John.
Thanks. Thank you, Matteo. Hey, good morning, everyone. My name is Hugo Smitter. I'm really happy to be here in more ways than one. I live in the west coast of Florida. So I know, yeah. So when I'm not tackling disasters, natural causes, natural disasters, I'm like you, tackling complex technology problems for our customers. And very excited to be here to share with you and to learn from you and with you. I work for FICO as a platform architect, and with other groups of platform architects. Our role is to help customers make better decisions faster and more profitable. Pretty straightforward goal. That's what we do. So I want to take you through a journey of how decisioning technology has evolved. What is FICO doing to stay ahead of the curve and help our customers make better decisions? And I'm being very specific of how I use the term decisions, because We have decisioning technology, and that's what this is about. But before I go there, I'll talk about some of the industry trends that are driving some of the winners in the industry. So winners are companies that are taking a decision-first approach powered by AI. As an enterprise architect, I always thought about processes first, process decompositions. You're looking at your companies and their business processes and data. So I would start modeling business processes, data architecture. When I joined FICO, I understood that looking at the world, looking at our businesses from a decision-first standpoint puts the emphasis of where profit is made, where costs are wrung out of the organization. So decisioning is where winners, and I'm glad to see companies taking a decision-first approach, and then everything falls in place when you analyze your decisions and optimize the outcomes of those decisions. So these three trends look disconnected, but they're not. There's a theme behind this. So number one is that the top performing companies have taken adopting a platform as a service. So the idea of platform as a service is a subtle one. It's the idea that you can break your company into services and capabilities that can be quickly integrated to provide more value to your customers, as well as better integration with your partners. The second trend is, not surprisingly, especially in the highly regulated industries, finance and in insurance, that leaders struggle implementing artificial intelligence. And the third one is that 47% of decisions are becoming more complex in the next 18 months. And I have a specific use case that will discuss that in more detail. So how are these trends playing along? How do they come together? So the businesses that are winning, they're differentiating themselves from the rest of the pack, have an approach that starts with trusting their data. Now, this didn't happen overnight. Companies are trusting their data because they invested in years of improved data governance, improved data ops, data observability. All the disciplines of data governance are now much better than they were 10 years ago. So the fruit of that investment in data governance has resulted in data that business can trust better today. So with that data, now you can orient AI to those decisions that are critical. I mean, it's not easy, and as you know, it's not straightforward or inexpensive to come up with AI solutions that are operational. Yes, you can come up with proof of concepts, but where exactly you can apply AI that is safe, that is explainable, and that is profitable, it's not easy. The winners are doing that, and we observe that. The third one is, yes, you can look at decisions, but how do you build an ecosystem where you can... companies, they're not all experts in all their decisions they make. They're not their core competencies, not all of them. So you partner with other companies to address those key decisions and build an ecosystem around the key decisions that you want to keep in-house or you want to externalize to other partners or work with your clients. So the fourth one is adopting platform as a service. So we are in this roadmap of adopting platform as a service because we can wring more value out of the services and capability that we offer, so we can provide more value to our customers and at the same time monetize that trajectory. So these are trends that all come together. So let me stop here and talk about who is FICO. Okay, so when I mention FICO, especially in the US, they say, oh, credit score. You're in the credit score business. And they even asked me, could you fix my credit score? And I said, well, I I cannot fix your credit score. But if I can borrow your identity and your credit card, I can bring it down for you. It's a guarantee. I can really ruin it. But seriously, FICO is more than scores. That's a very large part of our business. But we also have a range of services and capabilities that provide what we call applied intelligence. Applied intelligence is the idea that we can take our customers' data and apply 3 pillars of capabilities that we offer. One is decisioning technology. So the whole world of rules engines, of scorecards, and various paradigms to represent decisions is one of the pillars. The other pillar is optimization. So this is the whole world of mathematical models for linear and nonlinear mathematical models for optimization. And the third one is analytic, the whole spectrum of analytics, from the most basic scorecards, machine learning, and AI. When you take those 3 things and you take data with it, you can draw insights from the customer's data and take those insights and operationalize those back to the customer. And then you look at the outcomes in time, and then you repeat that cycle. So it's a virtuous cycle of improving how you make decisions at the end, right? What I said, it's smarter decisions, faster and more profitable. So that's what we do. And we've been doing it for a long time. FICO has been around for 68 years this year. And we made some improvements. We made credit easier to obtain. We have transformed the mortgage lending industry. And in the past 10 years, we lowered credit card fraud by 2/3. That's significant. Now, we are also in the journey of adopting platform as a service. We began with the score business. And like many other companies, we began developing software solutions, point solutions that grew as they have their own profit and loss. These are very significant products that address key problems our customers have. But through time, we realized that point solutions are not enough. We cannot deliver enough value to customers, and we cannot adapt with the flexibility. So we began decomposing our architecture, like we said, like you see in those trends, you saw in those trends before. And by decomposing our business capabilities, we wring out commonalities, we take out inefficiencies, and we develop these Lego modules that can be recombined in more creative ways, not just by us, but by our customers and our partners to provide better value. So we are in this journey of decomposing our capabilities. So the FICO platform is a game changer for us and for companies that have partnered with us. Now, of all those capabilities that we're providing to our customers, I pick one that I find very interesting and applicable for this conference, which is our fraud capability. So fraud is a very interesting space where on the life cycle of a customer, before you acquire them, all the way through the end of life cycle of a customer, you have acquired them and they're going through the life cycle in the interactions with your company. There are points of where fraud can happen. Well, fraud is a space that I have to compare to war. There's an arms race between the bad guys and the good guys. The bad guys are looking for surfaces of attack to the customer and the businesses behind those customers. And then the good guys, the reaction is to use data and use more smarts. And that drives an explosion of complexity to capture signals that you can intelligently apply to counter that attack. So it's not just the thousands of transactions per second that payment fraud and credit card fraud generate. It's not just that you need near real-time response. Not only that you have to correlate disparate events in time and reason around them to provide a response that is accurate and is fair and is timely, but also is that our customers are fighting this arms race by modifying their requirements. And when you don't have a platform, a middleware platform, an event service platform, component or architectural service, we call them architectural service. So the event service that serves the fraud capability, you can't change quickly. You're always in reaction mode, trying to scale and change the profile of your event service to serve those new parameters that the customer is demanding, and they're demanding quickly. So with that, I want to mention what we're doing today. So where we're heading. At FICO, we continue to decouple the point solutions that we have, decompose them, wringing out inefficiencies, and creating more smaller and modular components that allow customers to combine them in very creative ways. But there's a caveat to this, and it's the complexity of interaction between these components. So we need partners. We need a partner, and one of them is StreamNative, that gives us a component of our architecture that can scale, that can grow in a global manner, and adapt quickly to our needs. So with that, wrapping it up, close to wrapping it up, I want to mention that we went through a software selection process. I won't go into the details here. All the companies you see here are very capable, and they are tremendous in their offerings, very competent, and it was a hard choice. I think what made us decide towards StreamNative definitely was their contribution to the open source community. So we are in a journey of adopting, for instance, just one data item, we're adopting GitOps. So some of the contributions that StreamNative made to the open source community help us draw a roadmap that is friendly to GitOps adoption. And so that's one of them. The second one is not just that they met the performance requirements in our benchmarks, but the way they met it and the way they explained to us how the decisions they made, the choices and configuration choices that they made, gave us a good sense that they understood what they were doing, basically, right? That's what you want. And the third one is we are a Kafka shop. In fact, our core system's running on Kafka. So when we began this journey, we began with what we call our North Star. So the green field of things that we're building anew, less risky, we can be a little more revolutionary, if you will, because Kafka is the incumbent. And so with StreamNative and Pulsar, we demonstrated that we can use it, it does what it's supposed to do, and we deployed it worldwide. So recently we deployed StreamNative in Europe. Now we'll tackle our core systems. So at the end, these are the three factors that made us choose StreamNative for our choice of Apache Pulsar. So what's next for us? We'll continue decomposing established business capabilities that are operational and providing revenue is not easy for many reasons, right? You will understand. But we continue doing that because that is the right direction. And the more we do it, the better we can provide value to our customers and establish better relationships with our partners. We'll continue with event-driven architecture and event services. And finally, we'll advance our adoption of the StreamNative private cloud where we're running our current transaction systems. That's our goal. So with that, I'll wrap it up by saying that trusting data, using AI, and making better decisions faster and better is the way to go. And at FICO, we're moving in that direction and leveraging those trends that you saw earlier to provide value to our customers. And with that, I want to please thank
Good morning. Hope you enjoyed the summit so far. And I think there's a pattern with these two keynotes, essentially, is that every enterprise is going through some sort of platform decomposition and adopting one data stream technology or not just data streaming technology, but a platform technology that there's going through a transition of platform, and obviously OAM and DAP, all these cloud-native technology all coming together, bring the complexity behind the developers. So if you want to learn more, I would recommend talking to Hugo and Graf about the journey there. And also Hugo has a breakout session this afternoon. Definitely check it out. So before I can get started, I just want to maybe do a little interaction here. Show your hands. How many of you own a car? How many of you own a credit card? Okay, how many of you take an Uber coming to the conference today? Okay, how many of you making digital payments when you go out together with family and friends? Okay, so guess what? Many of these companies who create this convenience and ensure them are reliable, safe, and operate in real time are coming here to talking about how they're using data streaming technology to transform their business. So you will be hearing a lot of exciting stories throughout the day from Uber, Pinterest, FICO, Iterable, and we also have friends flying all the way from Korea that is coming from the biggest Korean search company, Naver. We're talking about how they're using data streaming in their business. So now let's talk a little bit kind of future. So I think in a lot of keynotes, we're kind of talking about, we try to support multiple protocols, hide the complexity behind the applications, and as well as doing this platform, creating a platform behind OAM. So we hide the complexity of the platform itself. So there's a transition that is happening in the entire industry and as well as the enterprise, and what is driving behind this scene. So a while ago, I will step back. A while ago, I write a kind of LinkedIn post. It's about my prediction about the future of Kafka. So I basically say, so Kafka is going to move beyond an API standard towards a storage standard. So it's not just like there's a fragmentation between, okay, do you want to choose RabbitMQ, Kafka, Pulsar? There's so many different messaging protocols out there, but the war of like these different protocols would eventually end by moving all these protocols from API standard towards storage standard. And when you're moving the Kafka from API standard towards the storage standard, the war of everyone is 10x cheaper than self-managed Kafka is going to end. And the second trend of this is essentially is the data streaming, the boundary between data streaming and data lakehouse is gone. So that manifests in two ways. So all these lakehouse vendors are going to introduce a streaming ingestion API. Whether it's Kafka API or its own API, it's going to happen one way or the other. The second pieces of that equation essentially is all these data streaming vendors is going to adopting open lakehouse format as their long-term storage capability. So the boundary between these two sides of the world is going to be gone. So in the prediction was originally made as the future of Kafka, but really is about the future of data streaming as a whole ecosystem. So in previous keynotes, we talk a lot about the architecture evolution from JMS, RabbitMQ to Kafka, Pulsar, and also there's many more innovation that is happening in the entire data streaming space. So all this innovation, past and present, are driven by one singular vision, that is making data streaming affordable, accessible, and scalable. So now, I'm going to kind of talk a little bit why we are seeing a lot of trend about this platform as a service, hiding a lot of complexity of this behind a framework that is able to help you focusing on developing application. That is because now we enter the age of AI. It comes with new shift. So just as Pulsar and many other technology was born to adapt this cloud-native architecture, we are making a shift, making sure data streaming became a real-time backbone for the AI. So here's a couple numbers. The 148 billion AI market is projected to go to beyond 1 trillion by the end of the decade. So that is about 40% of the CAC. But on the other side, if you're looking into the number of the developers, is projected for growing from 30 million to 35 million. It's only about 4%. So there's a huge gap in the ratio between market size and the number of developers. And how are we going to address these gaps? Obviously, is adopting a platform. Platform as a service is going to be the way how you address these gap. And you need platforms to making sure you shift your developer from focusing on self-managing your infrastructure, operating your infrastructure, towards more focusing on building application on top different infrastructure technology on top of AI. And that's why it's so important to see so many different stories talking about how they transform the enterprises to adopting a platform technology. So AI is kind of influencing everyone's daily life, whether it's through conversational chatbots or like smart, actionable agent. But for AI to kind of really reshape the entire world, we need a really strong and solid data foundation. So what does the data foundation look like? Everyone knows about foundation model, large language model. Those are the foundation of your AI. But those are typically trained and managed using some sort of lakehouse technology. But when you want your AI to really work, interact with the real world, to really understand the real world using your enterprise data, you need fresh real-time data streams to augment those data, those models. So more importantly, the next phase of the AI is going to move beyond conversational chatbots. It's going to take the real-time actions and perform tasks for people. So to enable AI to interact with the real world, a platform that continues provides reliable real-time data stream is essential. And this allows chatbots, AI agent, or is able to kind of take your enterprise data and respond to those events in real time. So in short, AI is not just transforming how we work with data, but also it transforming or reshaping the entire data infrastructure itself. So to truly harness the power of the AI, you cannot just simply say, OK, I will put all the data in my data lake, I'll solve the problem. Or I will just like using a data streaming, completely shift left, and just using everything streaming. It's expensive using data streaming. So you need both. You need to actually need both sides of the world because they are the two sides of the same coin. So that's where we want to kind of introduce a concept called streaming augmented lakehouse. So what does this really mean? We can get started with a simple diagram. That is a data lakehouse diagram. So essentially, this is very simple. You put everything, structure, unstructured, into S3. You have a unified metadata and governance layer, and you are able to access the data in an open standard. You can do BI, you can do AI, you can do different sort of things over the lakehouse. So this is lakehouse. So the idea of streaming augment lakehouse is quite simple. It's just we bring in the data streaming capability into a lakehouse and augment it with sub-second Kafka-like streaming capability into the lakehouse. So essentially combine the best part of the both worlds is you can use lakehouse to managing, training, and fine-tuning your models. You can use data streaming for augmenting those models, provided reliable, continuous real-time data streams into your model, making sure they are able to provide real-time actionable insights to your enterprise applications. So now you might be thinking, doesn't this sound like a Lambda architecture a decade ago? Yes and no. So it's quite different. You probably hear some of the other vendors talking about, OK, I can combine my Kafka broker, stitch them together with a lakehouse, and then offer this as maybe a data architecture that is able to do both data streaming and lakehouse. Or some of the approach will be probably adding a speedy layer over the lakehouse and combine all this together. But those are basically recreate Lambda architecture a decade ago. is because it ignores fundamental problem is that you need a unified metadata and governance there. So if you try to kind of stitch two different systems together, you are leaving your data isolated in two different like silos. You are not governing the same copy of data. So streaming augmented lakehouse essentially follow the same principle that lakehouse vendor is doing, is that I want to making sure all the data, no matter it's table stream, or augmented by one unified metadata and governance there. So it just stop one copy of the data. You can treat it as stream, or you can treat it as a table. It support different protocol, support different semantic. You can bring different engines into the same copy of the data. So in short, it's not just a revolution of Lambda architecture. It's actually a new paradigm to reshaping how we think about data streaming in data lakehouse. So why is this so important nowadays is obviously because cost, and the second is because of AI. As we enter the age of the AI became a dominant force in the industry. Data streaming, I mean, everyone is using that. It already became a de facto standard for building real-time data infrastructures. But the ability, when we enter the age of the AI, the ability to handle vast amount of real-time data became really challenging, is how we can operate this more efficiently and be able to deliver the insights instantly. So that became really important. And as you already mentioned before, is that there's a huge gap between the market and also the number of developers there. So that means we need to find a solution, a platform that is able to address that gap smartly. So that's how it became really important. And the other pieces is when you are using a data streaming platform and try to scale the data streaming platform, using a traditional technology will become really expensive. You probably pay tons of money to cloud providers for inter-AJ traffic. Every data streaming vendor became kind of reseller of a cloud provider. They just add up margin over storage, add up margin over like networking. It doesn't really bring values to enterprises. So that's how we kind of looking into the space, is that we really need to rethinking how we store data, how we stream data into the lakehouse in and out. And last thing is, when you want to do this for AI, is you need to bring these lakehouse and data streaming together. Traditional approach just basically enforce you to having two different systems, and you are enforced to transfer data between these two different systems. It's very costly. And when you bring all this together, integrating streaming with batch capability, you are often also need to introduce complexity and also high networking costs, and as well as redundancy across different systems. And that's why it's so important when we enter the AI, looking into how we shift in time mindset. We need a new system, new paradigm to think about data streaming in lakehouse. So that's why we kind of, over years, we create a system called Ursa Engine. So at a very high level, it's a 100% Kafka API compatible data streaming engine. It was evolved from Pulsar, but more kind of building natively into the concept of lakehouse using open standard formats. And it tried to use S3 as a primary storage layer and store data in open lakehouse format. Could be Delta Lake, Apache Iceberg. It brings the power of real-time data streaming into lakehouse and augment it to create a one unified platform that is able to help you build AI workloads. So Ursa Engine is quite different from others. So first is a lakehouse native solution. It's built on top of lakehouse. It removes the needs of transferring data from a data streaming system to your lakehouse. It's more seamless integrated with each other. You just stop one copy of the data. Secondly is unified, meaning you only have one copy of data in S3, and that can be presented as a stream, can be presented as a table. It's all governed by your existing governance tools, no matter like which catalog you're using. It's more cost-effective, meaning it's using S3 as both the replication and networking layer. So it removes the inter-AJ traffic, is able to kind of reduce your entire data streaming infrastructure by 10x. So this makes SI Engine the perfect foundation for building your real-time AI infrastructures for the future. So it augments Lakehouse to make it be able to support sub-second Kafka-like streaming capability. So today I want to kind of really excited share that SI Engine is now available as a public preview on StreamNative Cloud. And what does public mean? So it's available for AWS BYOC customer. It soon will be available for other cloud providers and as well as for dedicated and private cloud as well. It supports Kafka protocol. So if you are, but the latency is about 200 millisecond to 500 millisecond. So I would say sub-second like latency. So if it's acceptable for your workload, it's a perfect solution because it can reduce your data infrastructure running in public cloud by 10x. So if you're interested, scan the QR code. If you want to learn more, and obviously there's many different like StreamNative team here, you can talk to them. But now, for people who attend Pulsar Summit EMEA like in May, you probably already hear about SI Engine. So what's really new here? So I want to kind of maybe step back to kind of talking about the evolution of data streaming architecture, because I think that's something fundamentally new that we bring to the evolution of data streaming architecture. So first of all, let's take a look at the entire evolution of the architecture. So in my opinion, so this is just my opinion, so the entire evolution has 3 stages. So the first one is what I call leader-based architecture. The second stage is the leaderless architecture. The last one is the one we kind of entering is what we call brokerless or headless architecture. So what does it really mean? So most of the data stream platform we use today are leader-based. So we can get started from JMS broker. All these are kind of single broker. And you are using some sort of primary backup solution for HA. All the data was sending towards a primary broker, which is usually the leader, and the data is replicated to the follower. And this is the JMS world. It gets started. And Kafka entered the picture is the first distributed implementation. But still, it's using leader-based architecture. So I think a lot of people probably know it's called ISR, is for data replication. So all the data was sending through a leader broker, and the leader broker would just, actually the follower would just pull the data from the leader. So it's a leader-based architecture. Pulsar take the architecture towards the next stage is decoupled compute and storage, but it has a lot of benefits, but it's still leader-based. I'm not saying leader-based is a long architecture. What I'm trying to kind of bring up is the leader-based is actually an extremely good architecture for if you want to get single-digit millisecond latency for your messaging and streaming workloads, because in order to get extremely low latency, you need to send to something and avoid a lot of this slowness on the storage or on the replication side. So get leader-based architecture is good for single-digit millisecond latency, so it's unavoidable. So when we enter the next stage of the evolution, essentially is S3 coming into the picture. I mean, Pulsar was the first data streaming solution that support S3 as a tier storage, but a lot of innovation has happening in this space, moving the entire S3-based solution from tier storage towards leveraging S3 as a primary storage. And this represents a kind of a fundamental shift towards more what we call leaderless architecture. So meaning every broker can serve the writes and reads, and there's no single leader. And you can, any broker can just receive the producer request and save the data to S3 and serve the request from any other brokers. So how do we achieve that? It's actually done by a concept what I call the split of index in data. So we're kind of moving the index of the records itself towards a centralized metadata catalog services and keep using S3 as a data storage. The idea is very simple, but the idea is not something new, which I want to give credit to. This design principle is actually coming from a very old distributed log system called log device. I'm not sure anyone hear about that, but if you hear about that, that is the credit is going to Facebook team that developed the very awesome scalable log storage solution. The concept is very simple. It decouples the generation of the sequence of records from storing the data records itself. So in that way, you can make your entire architecture become leaderless, and any broker can serve the write request and read request. So now we have this split of indexing data coming into the scene. We're going to enter into the next stage of evolution of data streaming, which I'm going to talk a little bit more here, is right now we have this index moving towards more metadata catalog services and data stored in S3. And what's happening right now essentially is that you don't necessarily need a broker if we have a standard. So that's already happening in the data warehouse space and data lake house space. Is everyone standardized on a standard called Delta Lake, Apache Iceberg. Everyone can just read the data directly from a catalog services and get the information and be able to read data out of S3. So in the data streaming spaces, with the evolution that is happening, is going to happen with the similar evolution is that if we have a standard, everything stored in S3, and be able to serve from a catalog services, you are able to enter this evolution, what I call brokerless or headless. You don't really need a broker. The advantage of this true headless architecture essentially is data stored in your own bucket. You own it 100%. And it's stored in an open format, give you the freedom to choose your computing engine. In the context of data streaming, your computing engine is actually the broker. So it means you can have a broker. You can also, it doesn't need a really broker. So the broker essentially will become just like handling traffic routing, buffer, flexible subscription management, TTL, and many other messaging and streaming semantic could become the value add on to this broker, but your storage there could be just standardized in more like streaming capable like storage format. So this would actually drastically reduce the cost and also prevent any vendor lock-in, because everyone just talking in the same standard, and it doesn't really matter which format, which broker you're choosing. All the data is storing in the same consistent format. And that's what we are seeing the entire data streaming ecosystem are heading towards to. So what happened in the data lakehouse side is actually happening in the data streaming, and what we call this as a headless data storage architecture, and it's part of the core engine of Ursa itself. And we believe with this evolution that we're pushing towards more open standard in the storage there, it's going to creating more open and interoperable data ecosystem in the data streaming space. So the core of the Ursa essentially is what we call Ursa stream format. That it's not a new format. It's just, you can think about it's an add-on to the lakehouse table. It augments the lakehouse table, bring in sub-second Kafka-like streaming capability, because streaming sometimes is an overused term. I just want to add, making sure it's a Kafka-like streaming capability there. So you can use your existing governance tool to manage and govern the same set of data. Whether you treat it as a stream, whether you treat it as table, it doesn't really matter. And more importantly, you are no longer tied to a specific broker vendor. So you have the freedom to choose and switch brokers. So if one Kafka broker become really expensive and doesn't meet your requirements, and you want to move to a different broker vendor like StreamNative, you have the freedom to choose what makes sense for you guys. So what even exciting with Ursa, essentially you can plug in your own broker and try to develop more your own messaging like semantics, and you can think about you only have one copy of data but processing in many different ways, in Kafka way, in Pulsar way, in MQTT way, and also you can bring in your computing engine into the same picture without kind of moving data in and out. You don't need to kind of build like bespoke integration between systems. So it opens up endless possibility for innovations and flexibility in how you handle your data streams. So, but it's still closed source. We plan to open source it soon, but we're looking for like collaborations to make this become a standard and spec that we can adopt broadly in the data ecosystem. If you want to learn more, Matteo has a talk in the afternoon talking about the Ursa stream. The talk is No Keeper, No Limits. Don't miss it. So now back to what I mentioned earlier. So what's new? So we have another exciting updates here. Going back to our vision. So our vision has always been how to make data streaming affordable and accessible. So making data streaming affordable, meaning we have to kind of look out what is the most expensive part in running data streaming, and what have been the major barrier to prevent interoperability between Kafka and Pulsar, and I would say in general the broader data streaming ecosystem. So we kind of get started with one of the most challenging pieces in data streaming spaces is about intercluster replication. So this is a very major one. It's just the entire ecosystem is really fragmented. So traditional like intercluster replication, like in Kafka, you have so many different tools. Kafka Mino Maker, Uber has its own fork called uReplicator. Confluent has Confluent Replicator, class linking, all basically doing similar thing. But every team is just doing re-implement similar approach in different ways. And Pulsar also has its own built-in geo-replication for intercluster replication. Although Pulsar only have one, it's just because it's built-in, everyone can use it, so you don't need to develop an additional tool. But all these have a common problem, is they're using wire protocol-based replication, which means you need to go through networking, and networking is the most expensive resources in public cloud. So if you're looking into data streaming build running on AWS, is 90% of your cost is coming from networking. And secondly, all these tools are just working for one protocol. So either Kafka, either Pulsar. But if you want to replicate between Kafka and Pulsar, you need coming up with something new that prevent interoperability between different protocols and different community and ecosystem. So I'm excited to kind of announce universal linking. It's a cost-effective, interoperable data replication framework between different data streaming platforms. It's built on Ursa stream, we mentioned, because we're taking the principle that we use in the Ursa is to develop an open standard for streaming. So in that way, the replication became easy. You can just copy the data, save it in S3 in open standard. You can reload in a different system. So that's a reflection on how important having a standard in the storage layer rather than having a standard in the API layer. And it will save tons of the cost and also reduce your complexity in operating data streaming platform. So what's different here essentially is we're taking the same principle we use in the Ursa side, is use S3 as both networking and storage there. So the idea is quite simple. So if you have a standard open format, you can just link any clusters, and that cluster can just save the data directly into S3 using some open standard specification. And then you can reload the data through a broker that understands that standard. So in that way, you can moving data from Kafka to Pulsar, you can move data from Pulsar to Kafka, but the most important thing is you only save one copy of that data. So with universal linking, you can do a lot of things. You can do data backup into Lakehouse. If you don't want to replicate to a different system, you can just backup as the stream as a table, and you can query them. You can migrate your existing Kafka clusters towards more these open standard. You can upgrade your Pulsar cluster towards more open standard. And obviously, if you are building a global data streaming strategy for hybrid cloud and multi-cloud, you can use the solution to kind of link different cluster, different type of data streaming platform together. So it all sounds magic. So don't just take my word for it. So let's roll a demo. And I want to welcome Dustin on the stage. And the stage is yours.
So if we can go ahead and roll the demo, I'll narrate it. So I'm going to start by demonstrating the deployment of an BYOC Ursa cluster in our StreamNative UI. So if any of you have used our StreamNative UI before, this all looks familiar to you. In just a second here, I should start the instance creation process. Let's see if there we go. I'm going to start by creating the instance. And on the far right, you're going to select your deploy BYOC. So I've already deployed some of the resources into my my own BYOC cluster. I'm going to select Ursa engine here after I've created the instance. You can see it says Lakehouse-based, cost optimized. Bookkeeper can be opted in for low latency transactions. So we aren't going to actually use Bookkeeper in this case. I name my cluster and I choose my cloud environment where we've deployed an EKS cluster that's inside of your own cloud provider. And then we're going to just do multi-AZ and go onto the cluster sizing page. So far, everything looks pretty normal for your regular BYOC cluster. Except when you get to this page, you're going to see that you no longer have the option to choose the number of bookies and their sizing. But you are going to be able to pick the number of brokers and their size. And then we're going to go ahead and click Finish, and it's going to start deploying this Ursa engine-based BYOC cluster into your cloud provider. When I go back into the UI after it's been deployed, and if this was a brand new cluster and you were just getting started, you might go to the Kafka clients page, get some Java code, make a service account, select your authentication type, pick if you have schema registry, all that sort of stuff. So the engine is going to work exactly the same. It's just everything's going to be stored in S3. But we want to move on to another discussion, and that was Sijie's discussion of Unilink. And we're going to go through what a migration process looks like. Here I have a consumer running on the bottom that's actually pointing into what I'm calling a legacy Kafka cluster. So this has nothing to do with Ursa yet. And on the left, I'm going to produce some Kafka messages into that cluster. And it says published to the legacy Kafka cluster. And on the right, it's published and then consumed by the legacy Kafka cluster. Secretly in the background, Unilink is already turned on. And it's taking the data that I just published and is transferring it over into the S3 bucket of the Ursa cluster that I just deployed. So if I start my Kafka consumer from the Ursa cluster, we're going to actually see the data get consumed from that had been transferred over into the S3 bucket and picked up by that cluster. So here on the right, it's going to take a little while for the Kafka consumer to start up. But you see that it says published to legacy Kafka cluster and consumed by the Ursa cluster. And that was data that was copied by Unilink into the S3 bucket. At that point, we're ready to actually migrate the entire application and turn off the legacy cluster. So what I would do here on the far left, I think 1 second, I'm going to publish some data. Actually, I published more data to the legacy one to show it was working live. Now I'm going to actually turn off, or essentially say we're not going to use the legacy cluster anymore, and we're going to move our producers over to the new Ursa cluster. So now production has moved completely over. So I published to the Ursa cluster, and you can see that it's on the far right, it's published to the Ursa cluster and consumed by the Ursa cluster. So we've migrated the old data over using Unilink, as well as migrating the application over to the Ursa cluster. Going back into the UI, I do want to show that we are in a BYOC situation, so I have what's called a cloud environment, and that is StreamNative managing your resources in your cloud provider, like your EKS cluster and things like that, and the node groups. So here I've hopped into AWS. I just showed the EKS cluster, but what I'm more interested in is showing you the S3 buckets. So if I go into tiered storage, or sorry, not tiered storage, S3, I can actually go into the compaction folder, and I can see the data in Parquet format now as well after it's been compacted, and it's available in Delta Lake format. So with the old data that was on the first cluster, the legacy Kafka cluster, and the new data is now available in Delta Lake format. Here I'm going to do an example of using DuckDB to try and read that data that was both migrated and the new data from the application. So when I execute this, we're going to get a table back, and we're going to see the data that says published to legacy Kafka cluster and published to Ursa cluster. And all of this data is being read off of the new Ursa cluster. Since this is in Delta Lake format, there's actually many applications that you can read that data with. So while we're at it, I just hop on over into Databricks, and here I've created a table that references that data called Test Topic Summit. If I go into the Details tab, you can see the storage location is, again, that same S3 bucket, pointing to that same topic. And then if I go into sample data, you'll be able to see that there's a bunch of data that I published to the legacy cluster, and then a bunch of data that I published to the Ursa cluster. We can actually head back to the slides. That's the end of the demo, before the demo stops itself. But you can go ahead and see now that we've shown the deployment of the BYOC Ursa cluster. That's, again, in public preview. The unilinking to, in this case, I only did an example of migrating data, but Sijie had mentioned that there's many other use cases for that as well. That's going to migrate the data directly into an S3 bucket that is readable, and then eventually it goes through the compaction process that is going to make it readable in Delta Lake format, and then you can use any of the different technologies that would be able to read that. And Delta Lake's not the only one, as Sijie had mentioned. Also, Iceberg is an option right now, and I'm not sure exactly which other ones are going to be available soon, but that's kind of our demo of showing what's new in public and private preview from StreamNative. As you can see, it's very important that we also integrate with other applications. So the next thing we're going to talk about is I want to hand it over to Kundan Vyas, Staff Product Manager at StreamNative, and he's going to talk about our partner program.
Hello all. That was a great demo from Dustin, showcasing the power of Ursa in action. So to unlock the full potential of a data platform, it's extremely important to have an ecosystem around it. You know, there's a growing list of databases and applications which require integration with your data platform. And you know, just last decade itself, there are more than 100 new databases added to the market. The average number of SaaS applications which are used by any enterprise is growing from 15 or 20 to more than 100. So if we really look at all the integrations which a typical enterprise requires, there's a top 15 or 20% which are extremely popular and impactful. So it makes sense to build those integrations and support them for our customers. But what about the long tail of integrations which are not of as much impact, but still required by some other enterprises? We can't completely ignore them, but if we go down the path of building all those integrations and supporting them for our customers, that'll be an extremely daunting task for one enterprise to do. So we've been exploring to see if there was a way for us to collaborate with others to build and support these integrations for our customers. And that is when we decided to launch a StreamNative partner program. So I can see that there's some differences, but that's okay. Last month, we launched 3 different programs. Each of these programs are designed for StreamNative to work very closely with a partner persona type. So the technology program is something which we've designed to work very closely with independent software vendors. The idea here is to work very closely with them to identify and explore the synergy between the two companies, align on the goals and the vision, bring our respective strengths, and build a compelling, a stellar integration experience for our customers. So on that note of working very closely with the ISVs, I'm super excited to announce that we have onboarded 8 ISV partners to our technology program. So some of these partners are here today. So if there's anyone who represents these companies, please raise your hand so we can see. There's some there. Okay. There are a few of them here. So again, thank you so much for being a part of this program. We are excited about collaborating with you on this. So we already have more than 50 integrations in StreamNative Cloud. A lot of these integrations are available as fully managed connectors, and some of them are native integrations. So you can expect to see this list to grow rapidly now because we are now starting to collaborate more with our ISV partners. So while we continue to build integrations with our ISV partners and collaborate with them on product development, we also wanted to make sure that we support our customers with their end-to-end journey. And that is when we decided to launch a services program. So the idea here is to work very closely with system integrators and look at the end-to-end journey of a customer as they explore their data platform. Everything from evaluating a data platform to migrating to deploying their data platform StreamNative Cloud. We want to work very closely with our SI partners to really define customer success and focus more on that. So in the context of working very closely with SIs, I'm super excited to announce that we have onboarded 3 SI partners to our services program. Each of these partners come with a specific expertise in their own industries. And I think one of them, Nexaminds, is here, and they're also one of our gold sponsors. So thanks for them to be a part of this program. Let me see if there's anyone from Nexaminds here. Actually, nobody here. Okay. So they are actually a data and AI services company based out of nearshore Mexico, very US-friendly time zone. They have a booth here. So please stop by when you get a chance to learn more about how they can help you with your data platform journey. So we spoke about 2 programs, the ISV program and the SI program, the technology program and the services program for ISVs and SIs. So I'm now excited to talk about the 3rd program. And this program is mainly for the data streaming experts. The affiliate program is designed primarily for StreamNative to interact with the data streaming experts out in the industry. So anyone who's an independent consultant, who's in the advisory role, providing advice to different enterprises about the type of data streaming solutions or technologies which they recommend to the companies, this program is for them. This is an approach for StreamNative to open a channel to work with these consultants, to educate them about the value we bring to the data services field so they can collaborate with us. Once we educate them and convince them, hopefully they recommend us as solutions for, data streaming solutions for different enterprises. So if you want to learn more about this program, you can definitely talk to me or our sales teams. Let me see if there's anyone here from StreamNative sales team. There's nobody here. That's fine. You can talk to me, or for the folks who are watching this online, you can go to streamnative.io/partners, and you'll find a link to submit your request to learn more about this program and how, as an independent consultant, you can be a part of this program and collaborate with StreamNative. All right, so we spoke about 3 programs. The technology program for ISVs, the services program for system integrators, and the affiliate programs for the data streaming experts. While we are equally excited about all the partners we have onboarded, today I want to spend a little more time talking about 2 specific partners. The first one is Ververica. So as you'll know, Ververica is a company who's one of the original creators of Apache Flink. So we are super excited to partner with them for a program called the Powered by Ververica program to bring a brand new service to StreamNative Cloud. So with that, I'm super happy and excited to announce a brand new managed service for Apache Flink in StreamNative Cloud. So developers can leverage this service to run their stream processing applications within StreamNative Cloud. While the service runs on StreamNative cloud infrastructure, It is powered by Ververica's Vera engine. So you already heard about Ursa and the type of power it offers in terms of helping you reduce your infrastructure costs for your data platform. Now combine that with Vera, which is going to help you speed up your performance of your stream processing applications by multiple times. So we have combined the best of both to offer you a packaged service out of the box within StreamNative Cloud. So you can run your stream processing application and data streaming applications on StreamNative Cloud as your data platform. So to tell you more about the Vera platform or the Vera engine, I'd like to invite Ben Gamble, the field CTO of Ververica, on the stage. Ben?
Thank you very much. So just a quick show of hands. Who's had to fly in today or yesterday to get here? Quite a few of y'all. Me too. As you can guess from my accent, I'm from the UK, and it's a real pleasure to be here with all of you today, and some of you yesterday as well for the training. Working with StreamNative on this has been a real pleasure, as we've managed to bring, as we said, the best of streaming and stream processing together. At Ververica, we're kind of no strangers to trying to bring the best to stream processing. About 10 years ago, Apache Flink was open sourced by the then Data Artisans team, which became Ververica. And last week, we were in Berlin celebrating its 10-year anniversary. Now, as we've kind of released the Vera engine over the last year and started the Powered By program, we're bringing this to as many places as we can. We've always focused on trying to make real-time data streaming possible for anyone and everyone who needs it. And with StreamNative, we're bringing that into a flexible streaming processing, trying to bring a flexible stream processing engine into a flexible streaming engine to bring the best of both offloaded storage into both the streaming engine itself and into stream processing. At the core of this is that we are bringing that managed service into StreamNative directly. You get the best support possible for your streaming, along with the best support possible for your processing, bringing the communities together, the deep technical expertise on both sides, and of course the boost from both sides of the community, bringing together so you can have a greater collaboration with us and with StreamNative. Flink brings a lot to the party, a combination of data ingestion and processing, along with that ability to access all parts of the data inside a Pulsar ecosystem. Now, you've already heard a bit about Vera. Vera is the Vera application, the Vera runtime assembly. It was designed around 3 core pillars: streaming data movement, which is about getting your data in and out of your system; real-time stream processing, leveraging the value of your data in real time; and the stream house. This is, as we've all seen, data has got bigger, data has to still move fast, and there's no real requirement for data to be slow on the lakehouse. I'm not going to go into too much detail, as I have a couple of sessions this afternoon kind of going into this at great detail. But just to say now that a lot of work goes into something like this, because these systems have been around for a while, and that doesn't mean there's a lot of work has not gone into making them right. But as much as you have 10 years of open source evolution, it kind of takes a cloud-native revolution to really bring it to life. And we've always operated at scale. Ververica is the platform powering some of the largest Flink installations on the planet. We have clusters with over 2 million cores in management, moving over 10 petabytes a day, and single clusters with over 35,000 jobs. Now, at recent announcement, Netflix has pipped us at a few of these numbers, but we like to think we'll catch up soon. But then again, that's the power of open source. You get to play with some of the biggest pieces of technology in the world, with some of the biggest amounts of data in the world, and still be able to innovate. Sorry. Without that, I'll hand back to Kundan.
Thanks, Ben. That was really great to hear about Vera. And our partnership with Ververica is just getting started. We are excited about this collaboration. You can expect to hear more from us about this partnership. And now I'd like to talk about our partnership with Google. So firstly, I'd like to talk a little bit about StreamNative Cloud on Google. So StreamNative Cloud has been leveraging Google Cloud Platform for a while now. All our offerings, all our fully managed offerings like serverless, dedicated, and bring your own cloud, they're all available on Google Cloud. All these services, all these offerings are available either through StreamNative.io or through the Google Cloud Marketplace. Having our services available through Google Cloud Marketplace is really a big win for us because that makes it easier for us to make our products visible for the Google Cloud customers so that they can easily explore and try our products on StreamNative Cloud, on the Google Cloud platform. So some of the core functionalities or the products from StreamNative Cloud leverage specific infrastructure services from Google Cloud, like the connectors and functions and Flink. They take advantage of the compute services like Google Compute Engine or the Kubernetes Engine. And our storage services layer takes advantage of services like Google Cloud Storage and Google Persistent Disk. So there are so many other services which we'll leverage from the Google Cloud platform. So apart from leveraging the services from Google Cloud for our own offerings, we also integrate with various services within Google Cloud. So we have a whole bunch of fully managed connectors which are available for our customers to easily ingest data to BigQuery, Google Cloud Storage, Google PubSub, and more. So while we're excited about all the integrations, today I want to spend a little more time focusing on BigQuery. Oh, I think I want to actually cover one more slide. OK, that's fine. I think I'm skipping. Just quickly add that. So as you all know, BigQuery is one of the most widely adopted AI-ready data and analytics platform. And we are really excited to have an out-of-the-box capability which supports our integration with BigQuery. As a developer, you can get a pipeline running very quickly between StreamNative Cloud and BigQuery. And you can map all your topics as different types of tables within BigQuery. So this integration is exciting. Please try this out when you get a chance. But apart from this integration, we are also excited about one more new thing. We are happy to announce that we are certified as a Google Cloud Ready BigQuery partner who's been validated by Google for this program. So tell you a little more about the Google Cloud Readiness BigQuery program, I'd like to invite Naveen Punjabi, Director of Partnerships from Google Cloud, on the stage. Naveen?
Thanks, Kundan. And hello, everyone. I'm really excited to be talking to you all about how Google Cloud and StreamNative are partnering together and share more about the Cloud Ready BigQuery program. As you can imagine, Google has been at the forefront of the data and AI innovation for multiple years, and in fact, decades now. Many customers choose Google Cloud because of our unique, differentiated data and AI portfolio. And BigQuery, our unified data to AI platform, is at the center of many customers' data investments. But we all know customers do not use BigQuery in isolation. They use it with a whole bunch of ecosystem of solutions and tools that they already have or they plan to use. And that's where Cloud Ready BigQuery comes in. We need to make sure that customers have the best experience of using their tools, their solutions with BigQuery. And we take a concerted effort to make sure these tools work well. So what Cloud Ready BigQuery does is it goes through a validation process as well as recognizes all partner solutions that are optimally integrated with BigQuery. It's not as simple as taking an integration, running it against a bunch of tests and benchmarks, and producing a report. We go into a lot more detail into that, and we have Jobin at the back of the room who's been driving a lot of this effort around with many of our partners. What we do is anytime we work with a partner, we take a look at what is their existing approach of working with BigQuery. They sit with our engineering team. They sit with our product team with BigQuery, look at the roadmap. There is innovation happening on both sides, and we want to make sure there is a defined roadmap of the partner solution along with BigQuery. What we do next is we come out with a comprehensive set of core requirements that the integration should be meeting and the nice-to-haves, and then we validate the integration against those requirements. We publish all those detailed technical reports for our customers, so it's really easy for them to be able to configure the partner integrations with BigQuery as well as fine-tune it. So it becomes a really, really simplified approach for our customers to use partners, as well as they have the confidence that it's not just the partner solution, but also Google Cloud standing behind them. If they run into any issues with an integration, they can reach out to Google Cloud. We have a strong partner engineering team who's standing behind to make sure all of those issues are resolved. But what happens next is even more interesting. Many customers continue to use BigQuery to bring new use cases. And when they are bringing new use cases, they want to know which solutions they can use with BigQuery to enable those use cases. And typically, what they would need to do is go through a bunch of whole set of tools, evaluate all of them, run POCs, which takes time, and takes time away from actually delivering solutions. Cloud-Ready BigQuery has become a great framework for them to look at these solutions that have already been validated, run validation tests against those, and use those solutions. So it becomes really, really an easy process for them to pick the right solution. And what we have done is we've invested in something called as a BigQuery Partner Center, where we have many of the partner solutions that have been validated by BigQuery discoverable within the BigQuery UI. You can find out which of the partner solutions are offering trials. You can deploy it through that BigQuery partner solution, as well as know which partner solutions are available on Google Cloud Marketplace. So we have been at it for the past quite a few months, I would argue, in many cases, years. And we now have 100+ partner solutions who have been validated by our engineering team and product team with BigQuery. A lot of effort has gone into it, and I'm really pleased to have StreamNative join this ecosystem of partners as well. This makes it really easy for customers to be able to stream data into BigQuery and drive real-time analytics. So that's great. But I think our work is not done yet. We have a lot more collaboration in store with StreamNative. You saw the LIDB integration. You also saw Cloud SQL. We are at it to make it even better, and I'm truly excited about where it's headed next. With that, I'll pass it on to Sijie. Thank you.
Thank you.
Thank you, Naveen. Looking forward to kind of working more closely with Google Cloud. So thank you, everyone, to being part of today's keynote session. We have covered a lot of kind of exciting grounds from future of data streaming with streaming augmented lakehouse, open standard format, as our engine, to amazing partnership with Ververica, Google Cloud. There's so much more to come. But before closing this, I just want to say a few words here. I think the reason we kind of renamed this towards Data Streaming Summit is that you never use one technology alone. It doesn't matter it's Kafka, Pulsar, or messaging queue. It doesn't matter it's just like Kafka, BigQuery, Ververica. I think you're going to use many different tools alongside of your entire data streaming journey. So the best thing for all the entire data streaming ecosystem come together is able to kind of present how to use different tools and how to kind of transform the business towards real-time business and using data streaming technologies. So we are not done yet. So I highly recommend you go to all the breakout sessions where we will dive deeper into how data streaming is going to helping business like Uber, Pinterest, Salesforce, Naver, FICO, Iterable, and many more. These sessions are great opportunities to learn from industry leaders and explore how you can take your own data streaming journey into the next level. And remember, we always want to kind of hear from you. And please feel free to ask questions. through the entire event, share your thoughts, engage with our team. To make it a little bit fun, you might be able to kind of see this small pumpkin. So if you ask a question, you will get one of these small pumpkin, and then you go to the front desk and in exchange with a StreamNative swag. So feel free to ask more questions. You will get more gifts. So in closing, I want to thank you for joining us at Data Streaming Summit. We are excited you would see how you will innovate and shape the future of the data streaming. And let's continue conversations throughout the breakout sessions, during the hallway, and throughout the rest of the day. And enjoy the summit. Thank you, everyone.